B scientific series. 3. Can you jump up 8 feet on the moon? Answer is yes. Okay, I made this similar video before, but I improved the way we calculate how many feet you can jump up on the moon. And this new method is very simple and clear, and if you use that, probably you get A+ in the physics class. Okay, suppose you have the astronaut muscle, right? You need the muscle to jump up. It's generate F for duration of delta T. Now he's wearing a gear, so it's heavy, 120 kilograms, the normally 80 kilograms. Okay, and he can jump up 2 feet on Earth. The moon is 1/6. Even with a gear, he weigh only 20 kilograms. So the ratio of this is not M, weight is this much. Okay, I'm sorry, it's not weight, this mass. Even it's lighter on the moon, this guy has more mass, right? Because mass doesn't change on the moon. Okay, so his mass on Earth is smaller. The ratio is this. Okay, so according to the physics we went through, we have a physics series video. Impact force. That's impact force. Create the momentum. And this initial speed is going to be same as potential energy. And here you have to be careful. Potential energy is a weight function, but kinetic energy is mass. So weight and mass, you have to be careful. So this is by the human's muscle, the leg muscles. We create mv, the square divided by mass, which is gonna give this. So you put that in the equation, we get this one. And this equation is correct for Earth or moon. So on the moon, weight is 1/6, but the height change, h prime instead of h. Okay? So you equate that, then we can get rid of unknown, the muscle and duration time. This is unknown, right? Depends on how much muscle you have. Okay, so we can equate that. Then we get the ratio. The height you can jump up on the moon is simply the height you can jump up on the Earth times 6 multiplied by the ratio of the mass. Okay, if the man can jump up 2 feet on Earth, the same man can jump up on the moon 8 feet, no problem. So this is gonna be the equation. So whatever jump up on the Earth, on the moon, use this equation, 6h m over m prime. Okay, so this is the mass without gear. This is the mass with the gear. If we use the same thing, the gear, then it's a 1, so 6h. Okay, and if with the gear, man can jump up 1.2 feet, then say 1.4, then it's going to be 8 feet. Okay, so this is the equation. Now, friction on the shoes, like walking on ice. Okay, let's consider this physically, using physics. Okay, suppose the body is leaning by angle theta, right? And this is weight. The weight is 1/6. Okay, so this component is this. The force acting here, you give a kick, you get the friction action reaction. So normally the kicks on the earth, you get the reaction only 1/6 because whole thing's 1/6. So this component is this, right? So tangent theta is actually friction coefficient, which is about 1.1 to 0.5 if you put the shoes on the sand. The sand is kind of slippery, so coefficient is not that much. So you have to maintain this posture and move. In order to move, you kick the forward movement you get on the earth, you get only 1/6 of the movement. So it's like you try to move, you move only 1/6 of the distance. Okay, and that's why you have to keep posture leaning forward, increase the forward parallel motions. So the theta has to keep the large to walk normally. Okay, even jump, you get only 1/6 of forward moving kicks. You kick the way you kick on the earth, you get only 1/6. So it's like slippery. Okay, if you are on ice, try to walk, it's slippery. You give a muscle, you kick, this vector is maybe 1/n. The same thing happening here. So in order to jump, you have to jump this way, but you need to have a forward moving force. So you have to lean the body forward. You lean the body forward, then you kick at the direction of the center of gravity, then it jump up like this, and that's the way you can move. Otherwise, moving is like a very stupid move. You try to walk, it's like walking on the ice, leg moving, but it's just moving inch by inch, right? Usually you move 2-3 feet. The six is like half feet. Every time you walk, only half feet moving. Okay, so without leaning the posture forward, you cannot walk very well. So that's what is going to happen. Okay, so I hope you like this video. If you like, please subscribe.